Section 4.2 Amplitude, Reflection, and Period. We're going to look at the amplitude of the graph and the behavior of the graph that is reflecting about the x-axis and the period of the graph. For the amplitude, recall in a previous section, the graphs of y equals sine of x and y equals cosine of x have an amplitude of 1 and a period of 2 pi. The amplitude is computed by using 1/2 multiplied by the absolute value of the difference of the maximum and the minimum value of the graph. And the period is the smallest integer number that the graph repeats the same pattern or it finished in one cycle. The graph of the sine of x, like y equals sine x, the 5 key points from 0, 1, 0, -1, and 0. So the behavior of the graph based on the 5 key points from 0 to 2 pi, it breaks it up into 5 different points with the 4 interval as pi here and pi over 2 and 3 pi over 2. Locate the order pairs with the 5 key points. At the point 0, the graph is 0, the function is 0. At pi over 2, the function is 1. At pi, the value is 1. At 3 pi over 2, the value is -1. And at 2 pi, the value is 0. And then we connect all the curves together. So we get the sketch graph of y equals sine of x, where the graph of y equals cosine x consider the same 5 key points. So starting with 1, 0, -1, 0, and back to 1. Sketch the graph, the maximum 1, minimum -1 from 0 to 2 pi, which is in one period of the graph or one cycle of the graph. Break it up into 4 equal subintervals, 0, pi over 2, pi, 3 pi over 2, and 2 pi. At the point 0, the function value equals 1 or the maximum value, and then go to 0, -1, 0, and 1. Connect all the graphs. So now we get the sketch of the graph of the cosine x. And this that confirm that the amplitude of both graphs equals 1 because the max is 1, the minimum is -1. You subtract them and then divide by 2. Another quick way to consider the amplitude is the distance from the midline of the graph to the top of the graph. So this is the amplitude. Let's consider the example. We're going to make a table of values for the following functions using multiples of pi over 2 for x, and then use the entries in the table to sketch the graph of each function for x between 0 and 2 pi. Our function is y equals 2x. The main function is the sine function. So based on the 5 key points at the point 0, the y value is 0, which is the second coordinate. At pi over 2, the sine function is 1. At pi, the function value is 0. At 3 pi over 2, the function is -1. And at 2 pi, it's the same value as at 0, which is 0 value. As we list the 5 key points, I'm going to list 5 key points here, starting from 0, 1, 0, -1, and 1. When you complete the table, as you see the increment of the x from 0, pi over 2, pi, 3 pi over 2, and 2 pi. And 2 pi is the period of this function size. So to compute it, it's going to be 2 and multiply by the value of the 5 key points, 2, 2, 2. And the 5 key points based on what we listed here, this is at an angle 0. And the next one is at an angle pi over 2. The next is at an angle pi. And the next is 3 pi over 2. And the last one is at 2 pi. So we fill in the parentheses here. So 2 multiplied by the sine value, which is 0. And the next key point is 1. And then 0, -1, and 0. Complete the number. That means at x equals 0, y equals 2 sine x is going to be 0. And following by 2, 0, -2, and 0. To set up the order pair, we have the x as an angle and y as the function y equals 2 times sine x. So going to be pi over 2, comma 2 for the second coordinate. The next one gonna be pi comma 0. Next one is 3 pi over 2 comma negative 2. The last one is 2 pi comma 0. And then to suggest the graph between 0 and 2 pi. In the graphing area, this is the xy plane. This one is the x, the horizontal one is the x, and the vertical axis is a y. Starting with an angle 0, the next is pi over 2, and the next is pi, and then 3 pi over 2, and then 2 pi. So 5 key points, and we're gonna locate the value for the y on the graph. At 0, the function value is 0. At pi over 2, the function value is 2. So this one, we're gonna make the scale of the y to be like this is -1, -2, +1, and then 2. At pi over 2, the function value is 2. At pi, the function value is 0. At 3 pi over 2, the function value is -2. At 2 pi, the function value is 0. And then we're gonna connect all the points together with the smooth curve. And then we get the graph of y equals 2 times sine x. From this graph, you can see that the red curve is the curve of y equals 2 sine x. Comparing with the blue curve, which is the graph of y equals sine x, the difference is the height of the graph. The maximum of the blue curve or the basic sine function is 1. And where the maximum value of y equals 2 sine x is at 2, both of them have the same value of the period, but the difference is just the amplitude. So when you multiply the function sine with the number or the real number, that will tell you something related to the amplitude. You multiply by 2, that for the translation concept of the graph is stretching the graph vertically with the factor of the 2. So that's why the graph of y equals 2 sine x is taller than the graph of y equals sine x, which is a basic function.